Hi, everyone. This week we have a very simple lab, but a bit more of an involved lab report. So I'm going to go ahead and go over it. So first of all, I want to highlight the importance of watching your pre-lab videos this week. In your pre-lab, there's a video about colligative properties, which is what this lab is all about. This concept may be new to you or something that you've just very recently learned. But essentially the whole idea is this equation right here, is that all sorts of chemicals have this freezing point depression constant. And whenever you add an additive to a liquid, it makes the freezing point go lower. So let's say you have water. Everyone knows the freezing point is 32 degrees Fahrenheit or 0 degrees Celsius. But if you add something like salt into it, it will actually make the freezing point go below 0 degrees. And so each chemical has this freezing point depression constant. And you take this constant and you multiply by molality. So this little m right here is molality, not molarity, molality. It is the moles of your solute divided by the kilograms of your solvent. So if you take that by your constant, it gives you the freezing point depression. So it will drop the freezing point by a certain number of degrees. So I want to highlight that freezing point depression is not taking longer to freeze, although it will take longer to freeze, but depression is referring to the drop in temperature itself. So let's go over what your lab is going to be this week. It's very straightforward. You're going to get 5 grams of terpbunyl, and terpbunyl is a liquid. So 5 grams, if we want to figure out how many milliliters that is, you take the grams divided by your density. You look it up, the density is 0.78 grams per milliliter. So you find that you're going to be getting 6.41 milliliters of terpbunyl. So 5 grams or 6.4 milliliters. And then you're going to heat it up to 50 degrees and you're going to start recording your data. And then you're going to put it into an ice bath and you're going to watch until your temperature stabilizes when it only changes by plus or minus 5 degrees Celsius. So it should only take a few minutes. And you're just going to repeat this 3 times, but on your second trial, you're going to use zero point 0.3 grams of benzoic acid. Your third, 0.61. And your fourth, you're going to use camphor, and you use 0.38. And all it is observing how much your temperature decreases. What you're looking for is we have our base right here, and each of these 3 chemicals right here, since we're adding an additive, we should see a freezing point depression like this. And so we want to see which of these has the largest freezing point depression by seeing which one hits the lowest temperature. That is the goal of this lab. So like I said, pretty quick lab, but let's go over all of your data analysis and your discussion. So first, it's going to tell you to find and reference the freezing part of terpbunyl. So just look for a database where it has this, maybe one that we've looked at before. There is one very popular one that we've looked back in our references activity and recitation. So just find a published value of the freezing point of terpbunyl, and then you have to cite it. Citing's half your credit for this question. Number 2, it's to calculate the molarity and the molality in both trials 2 and 3. So this one and this one. So remember, molarity is moles divided by the liters of solvent. Molality is moles divided by kilograms of solvent. So these are going to be different numbers. Next, it's asking if the temperature changes were gradual and how might the method of obtaining our data affect the temperatures measured. So just look at your data from your lab quest. Did the temperature change slowly, quickly, or what? And then could the fact that we used a thermocouple affect anything with the temperatures measured? Or perhaps using an ice bath, could either of these have an effect on the temperature measured? And then our final data analysis question is, did benzoic acid and camphor have different effects on freezing points? So did one depress the freezing point more than the other, or were they very similar? And then explain based off of their chemical structures on why there was or was not a difference. So for your discussion, the first thing it's going to do is ask you to compare and contrast the freezing point depression for the different trials. So this is not something you're calculating. That's a common misconception. This is purely based off of your data that you collected. So which one had the biggest freezing point depression? So what you would do is you take the lowest temperature from trial 1 and subtract the lowest temperature from trial 2. That's your freezing point depression for trial 2. For 3, it'd be 1 minus 3. For 4, it'd be 1 minus 4. So you're just taking your lowest temperature here when everything's froze and subtracting by when everything's froze here, and compare and contrast those. Next, explain your data. Uh, talk about how that has made you feel about freezing points. Are they static things? Is freezing points constant, or can freezing points be a little bit different from their measured value? Can they be above, or are they always going to be lower than their pure freezing point? And finally, talk about your observations and how they make you understand your liquids, how liquids freeze. I want to emphasize this question is different from the next question we're going to go over. This is talking about how your observations help you understand. So make sure you're taking decent observations. And that is it for your discussion section. But now we're going to go on to our next part, which is about making tables. So a large part of your lab this week is making data tables. It right here, it mentions that you can find information on how to make a meaningful data table on Canvas. So if you go to the lab and recitation page and you scroll down to lab report help right here, there is this right here, which is crafting meaningful tables. So if you need help making tables that would be good for your lab report, this should be your first resource. So y'all can look over that on your own time. But you're going to be doing several questions about making tables now. But first, it has a few questions for you. It's just asks you to describe the freezing process, including molecular details, and what changes when an additive substance is included. So you need to make sure you show a molecular understanding here of what happens whenever things freeze, and why adding other chemicals makes freezing more difficult and depresses the freezing point. For question 2, we have it says to give 2 or 3 sentences that summarize your data and the reaction that occurred. So does your data really indicate that you have added in additives? Do you see a freezing point depression? And talk about that. And now we're on to our table portion of the lab. So first it wants you to make a raw data table. So first it asks you to list the types of data you collected for each part of the experiment and to make a table of that raw data. So it says to include all measured values, but I do not want that for this lab, because if you look at your procedure, you are going to be taking a sample, 10 samples per minute, which is one every 6 seconds. I don't want that many readings, frankly. So just make a table of your lowest and highest temperature for each trial, and that's good with me. But do make sure to list the types of data you're collecting as well. But for your table itself, just include the highest temperature and the lowest temperature. Okay. Next for 4, it tells you to determine the freezing point suppressions of trials 2, 3, and 4. Uh, so again, this is the same as um, comparing and contrasting the freezing point suppressions, except this time you're also going to be giving numbers. I guess they're honestly pretty similar. Um, So if you give me the same thing here, if you want to include numbers for both, where is it? This question and for this question, that's fine with me. Question 5 is where things get annoying. It's asking you to make 3 versions of a summary data table. And it does mention here that you can use the same data, but you can rearrange it and make a new table. So let me give an instance here. So let's say we have something like this here where we have the moles used, and then we have our freezing point depression. It would be better to have molality here and then freezing point depression. You could organize by increasing molality, and that'd be one table. And then for another table, you could organize by increasing freezing point depression. So they actually may be the exact same tables, Your data's probably not going to be perfect and it's not going to line up perfectly. But if you want to, in one, make your organizing factor your freezing point depression and another your molality, then that would be two separate tables. So you are just going to be manipulating the same data into multiple different ways to demonstrate trends is your goal. I hope that makes sense. So this doesn't have to be super complicated. One thing I do want to emphasize is that you should not be making graphs here. We want tables. So it needs to be something like this. It cannot be graphed data. In question 6, present a data table for your calculations in number 4. So if you showed a table with all your freezing point depressions in it, and number 5, you can just copy and paste that for number 6. If you did not do that for number 5, you're going to have to make a table that shows off your freezing point depressions. That's what it's saying right here. And then it's asking, does it represent all the experiment well? And then describing the significance. Final question is just if each trial started at 10 grams of terpbutanol, what would have changed? So um, pretty straightforward on that one. If you have more terpbutanol, would that affect your molarity and your molality? And then would that in turn affect by how much of a freezing point depression you saw? And then explain. So there you go. I know that this is a bit of a painful lab report. It's painful for me to grade, but um, people generally do pretty well on this report. So I have faith in y'all.